Thanks, Michelle. Everyone who's in the Miro, just before I do my section, if you are not following the presentation, please remember just to go back up to the top right-hand side and press join, because I can see that some people are still not managing to follow Colin again. So hopefully you should be able to see the frame now that says, what output will the following program produce? If you're there, you're in the absolute right place. Okay, so hi everyone. Let's get those cogs turning to get us started. On this frame, you can see I've got a block of code, and your task is to work out what it is that we are doing. I'm going to give you all a couple of minutes to read it over, and once you have an idea in your head of what the answer is, I want you to give me a wee thumbs up. So don't type any answers anywhere, just give me a wee thumbs up of what you're kind of thinking the answer would be. Okay, so most of you have had a little look over it. I'm going to make it slightly easier and make the answers multiple choice for you. So what we've got here is a little poll. There are 4 choices to choose from. Let me just start the poll so when we're ready we can. Right, 4 choices to choose from. Have a read and see if the one that you were thinking of the answer is there. And if it is, vote on what you think is the correct answer. Okay, so it seems that for the most part, we've agreed on the answers here, but the importance of this type of question, however, is not really the answer in the question itself, but rather in the explanation that we provide for why we've made this choice. So as teachers, we already naturally do this in our classes, but can be a bit more tricky for students. And as they panic, they often just pick what everybody else has selected and they hope for the best, okay? So let's talk about the why behind the answers that we have here and what we might be expecting from the pupils as to whether the answers might be correct or not. So let's have a little look at answers A and B. Nobody went for that one. So those two can actually be lumped together as mutually wrong, because we know this, but because regardless of the value of the variables themselves, the output line at line 6 that we can see in the code there clearly shows a concatenated sentence that has area and perimeter both being mentioned in it. Therefore, those answers are automatically wrong. Okay, if we look at option C, which is the answer that most people voted for, this is actually the correct answer. So well done if you selected that one. That's because the program will output the wording in that sentence and the value of area along with the kind of initial value for perimeter. Although a perimeter value was calculated in the function, it's not actually returned to the main program, and therefore that's just left at the initial value of 0. Okay, for option D, we could hope that the pupils would mention the fact that the functions can only return one value. That would obviously be that higher order thinking. And in this instance, only the area is being returned. So therefore the perimeter is calculated but isn't returned, and as a result doesn't appear. And you'd be hoping that pupils would be telling you those sort of conversations when they're voting rather than just being multiple choice. Now, this question is more than just a multiple choice question as a starter. So let's have a little look at some of the reasons why. So these type of questions are called peer instruction questions. If any of you were part of like the Plan C upskilling that we did a few years ago, when the course has changed, you might have actually seen them before. They're one of the resources that I still use in my practice every single year, and they really help the pupils understand a concept or a misconception loads better than not using them. Peer instruction is a pedagogical technique which was developed in physics actually years ago, but has since had considerable success in computer science. Essentially what happens is you have a multiple choice question, it's posed to a group or a class, and the pupils are asked to solo vote first on what they think is the correct answer. And this can be done in a number of different ways. You could use clickers, for example, QR codes for like clicker style. You could use online voting, individual whiteboards or show me boards, or I often quite just use like a eyes closed, hands up sort of thing to take in the votes. I like to, when I'm doing it, keep the answers anonymous between the pupils and the teacher for the first vote, as I think it's really good to get a feel for who is understanding this initial answer, like, or who's not, who's getting incorrect. Once the pupils have voted, the class is kind of meant to be split into groups, and then the groups are asked to discuss their options, make it clear that even if they all agree on the correct answer, they should still be kind of discussing the why they all agree. Why is this answer right? Why are the other answers incorrect? And it's important that the members of the group or the team that the kids are in can justify the group's choice completely. So everyone should be able to answer those questions. Hopefully at this point after the discussion, each group will have come to consensus about what they want to do their team vote for. And at this point, the teacher then asks the group to publicly share which answer they've decided as a team to go for. And it's then our job as a teacher to facilitate a kind of class-wide discussion on what the final class answer should be, with justification, of course, prior to revealing the correct answer. Hopefully, the stronger pupils in your class have at this stage helped convince the other members of your class of the correct answer, and the final stage is really just confirming what the class in total has concluded. But sometimes when you get to this final stage, the pupil's final answer may be wrong, and that's the time where you as the teacher need to step in, unveil the correct answer, and discuss why they were wrong. This isn't always as easy as it sounds, but again, we're always kind of brought back to that why. Why peer instruction over other questioning techniques? Well, studies, one of the ones completed at the Ontario Institute for Studies in Education at University of Toronto, they've proven PI to be very impactful. Peer instruction has shown to improve final exam performances over standard lectures. It reduces failure rates, it's contributed to increased retention, and it is widely valued by students. They really, really enjoy it, and I'm like, that's true. I can see it from my classroom. It can be hard to obviously completely evaluate what this specific questioning technique impact has within different levels of learning. And all learners obviously have a different level of skill, but research has shown that class-wide led discussion, that bit at the end where you're discussing with everybody, following them actively talking about themselves, that's the most valuable contribution to the success of this strategy. I think statistically wise, around 22% increase in pupil performance was shown after the use of this as a class-wide technique. But that being said, even a 14% increase was shown with just the pupil discussion. So it's important to consider, however, that this is only going to really work if you've really considered the relationships in your classroom placement, seating plans, and then when teacher input is being used and how that's being used effectively. Often I find that when I use it in my class, I completely move the pupils about so they're not sitting next to their peers. I think it helps when pupils are discussing it, that they're discussing it with pupils who aren't necessarily like they're close to or ones that they know well. And that way there's no predetermined like who is the smartest person in the class, because sometimes when you've got closer like friendship circles, they'll automatically be like, oh, that person knows the answer. But you have to be careful because you need to try and develop a community of sort of trust that facilitates good and effective communication in your classroom, which can be a wee bit tough with computer science pupils sometimes. And there's that danger that some pupils like might completely disengage if they don't feel comfortable enough to state their opinion. So it's a bit of a tricky balance to achieve to get it right. What I've done on this slide is I've added a couple of links to academic research on the use and benefits of peer instruction if you want to have a look at them at your own leisure. In case you want to look at any of them, they're up on the top right hand side on those little books. And I'm going to finish off my section at looking where we can make a use of this in our actual classrooms. So although it seems easy and obvious that PI questions can be used for coding and checking that various constructs work as intended, like that's where it's mostly used, it's good to remember that actually this type of question technique can be used in all areas of computing science and national qualification courses. On this frame here, I've added some examples of this in practice. So you can see, given the right context, you can technically use PI for any stage, any level, or really any subject, but it works particularly well for computing due to the high level of problem solving and that sort of like common misconceptions which arise in the content of our courses. So let's have a quick look at how we can use this in different sections of some of our courses. So you can see this one here in question 1 is a National 5 systems question, getting pupils to think about where in the computer data is held during operation. It's bringing in bits of software development knowledge too, where it mentions the running total or variable types, but hopefully that wouldn't confuse the pupils too much and they can still drill down to the important information. So where is the data held during the program's running? And we're hoping that they would know at this stage it's the RAM and be able to justify why that's the case. This next question here is another programming one, but this time it's from National 5. So the focus is on the common error that pupils can mix up during the standard algorithm of a running total. If you look at the code closely, you'll actually see the total is not incrementing every time the loop goes round, but instead it's being replaced. And one of the more complex National 5 concepts, that's one of the ones that they get tripped up with quite a lot. So you can some really good high quality discussions with pupils around the tables when they're discussing it for this one. This could easily be adapted to a programming language of your choice as well. So it doesn't have to be written in SQL reference language, you could obviously do it in Visual Basic or Python in particular if that's what it was that you taught. This next question here is also a National 5 question, but it's for databases and it's about sorting. So a sample output has been provided, very similar to what you'd find in an exam paper, but instead of asking the pupil to work out the sort order, they have to justify which of the answers is correct, but also why the other ones are incorrect, which is sometimes part of like a bit harder. So noticing how this has more the standard, it has more than the standard kind of 4 answers that you have. So it's not strict in PI to have 4 answers. A lot of the examples that you'll see do. You can have as many or as little answers as you want. You can just choose what's appropriate to what it is you're trying to ask, as long as the students have time to be able to justify their thoughts for all of the answers. And the final example here is a higher web one using the on mouse over, on mouse out JavaScript tags. They're calling functions to change an image, and the pupils need to work out what the functions are doing and then justify their answer. Again, this is being used to get that deeper level of understanding by explaining the code to a peer or to the class. Again, I've added to a link to a wee website at the bottom there on the bottom right-hand side. This last example that I got actually came from that website. And it's kind of based a little bit on some of the old ISDD versus STD units, but there's still plenty of relevant content that you could use just now for your classes or in BGE. Plenty to get started anyway, if you want to kind of see the format of the questions. And you might want to come back on and grab that link later on to have a little go of it. So now that we've had a look at some different types of questions, let's finish off by having a look at where we might use them. So here are some of the places in my classes that I actually use them just now, but you might find that you use them in different places. A great way to get the class of the kids in your class to sort of leave thinking, as I call it, when they're thinking about a topic, is to use a PI question as an exit pass. This is great with something if the use of plickers, if you've ever used them. You can quickly grab everybody's answers if you leave the room. And if you haven't used them before, basically what they are is every pupil has a QR code, and depending on how they hold their QR code up, they can take in the answers A, B, C, D on an app. If anyone's got like iPads or things they use within schools or Chromebooks, it's a really quick, easy way to do it. And basically you could just scan the kids as they leave your classroom. It's nice to know which individual pupil voted for what to kind of keep a track of their own personal progress. But once you've gathered that information, the pupils can leave, and in the corridors they can discuss as much as they like about the problem that you've left them with. And then once they return the next period, you can use the same question as a starter, which is a great way to jump back into what you were previously learning and see if they've managed to retain or understood, or even maybe had some of those high quality questions like outside of the classroom, and see if they get the content. The most common use of PI questions that I personally use in class is to assess prior knowledge, or sometimes if I've got crashes in the class, kind of raw talent at the start of a new unit. So it works really well with software development, obviously, as you can make it a question with maybe poor readability, so even good pupils might get tripped up. But it doesn't have to be in a specific language, but rather like focusing on the problem solving skills that we use to train the kids. I like to like reassess and repeat the task again at the end of a unit. So I usually do it at the start of higher STD and at the end to see how much the pupils have improved, and to give me a quick indication of maybe who isn't getting some of the logic. It gives me a nice quick overview to see who to focus on when helping during revision that comes prior to like end of topic assessments and stuff. Another good example is to use PI to focus on common misconceptions. You know the ones like if you're looking over 2's complement, students often make mistake about the sign bit's value, which side you fill up the mantissa from, like the sign bit is included in the mantissa's bit value and all that sort of stuff that you get in with 2's complement. So what you could do is use a PI as a kind of worksheet, which you can see here. There's some examples on the board, and then have listed at the top the common misconception, and then a question with answers, and then have a space for the answers to be justified or unjustified, depending on if they're right or wrong. And this can be issued as a classwork, as a homework task, where pupils are given this PI question and then asked to justify whether the answers are correct or incorrect. It might even be a good activity to get pupils to make up their own PI questions to share with each other, allocating perhaps their own common misconception. You could give them a focus to assess, and that should help them hone their understanding and further even still. And it could work well with the right pupils who've had exposure to PI questions in the past, potentially, and understand how they work. So hopefully this has given you a wee look into peer instruction and how you might put it into practice in the classroom to help formatively assess your pupils, as well as bring a bit of class discussion as to what can be some very higher order thinking conceptions. I've collated some examples of PI questions with answers and justifications for you guys to try it with your pupils, but I've also popped them in there, a copy of the templates. So they're all going to go in the swag bag for you to access a little bit later. And as I said, the template's there, so if you want to use that to get your kids to try and make up some by themselves and give them a misconception each, then they could have lots of fun. So that's my section over. Next up is Colin, who's going to be chatting to you about some of the other formative assessment techniques and how he has specifically applied them when teaching web content at National 5 and higher. So over to you, Colin.